Today we're going to continue with some further triangles, and this time, in these questions, we're going to be solving for the denominator. So what you might have noticed was in our previous lessons questions, all of our pronumerals ended up in the numerator, so all we had to do was multiply the denominator across and then put it into our calculator. It's not always going to be like that. Sometimes you'll have pronumerals in the denominator, so you need to know what to do with those. So let's have a look at this first question. Pretty much the steps are exactly the same. It's just when we get to the solving, it's a little bit different. So question 1, find the value of the pronumeral in this following triangle. So again, like what we did in our last lesson, we're going to label the hypotenuse, opposite and adjacent sides. So opposite the right angle, we can see that's our hypotenuse. Ooh. Line through the middle, that's pointing to our opposite side, and then the remaining side is the adjacent side. So we can see we've got a value for the opposite, and we've got a value for the hypotenuse. So O and H, remember so, ka, toa, that's going to be sine. So sine 55 degrees equals to, now it's O over H. So remember, so opposite goes on the top, the hypotenuse goes on the bottom. So that's going to be 80 over W. So you can see here the pronumeral has ended up in the denominator. Now how we can go about solving this is we don't like to have any fractions. So what we're going to do first is we're going to multiply the W across. So then we've got W times sine 55 equals to 80. And then what we can do is we can take the sine 55 and divide it over. So when we divide it, it does turn into a fraction. So W is 80 over sine 55 degrees. And then that's how we want to put it into the calculator. So you can put it in as a fraction, so 80 over sine 55 degrees. What you need to ensure is you close the bracket in your calculator or it's going to come up as a syntax error. So close the bracket, press equals, and we have 97.66. Or if we want to round that to the nearest whole number, that's going to be 98 meters. Whole number. Now, there are also shortcuts that we can do because when we're trying to write it as a fraction, remember you have to put that close bracket on. But what actually happens is if instead of writing it as a fraction, I actually write this as a division and I type it in as a division, you can actually, it's a little bit of a shortcut. You don't actually need to close the bracket at the end of your expression. So you might want to put into your calculator A divided by sine 55 degrees. And then if you don't close the bracket on that, it'll actually still give you the correct answer. Now, we also want to see if we can have further shortcuts. Now, if we start with looking at this expression and the one with W here and compare them, what you may have noticed is that the only thing that's happened between these two fractions is that we've swapped the sine 55 and the W. So in actual fact, when we're looking at this expression, sine 55 degrees equals 80 over W, a short way to look at it is all we're really doing is swapping the sine 55 degrees and the W over. So then you can go straight to W equals 80 over sine 55. And then you can put that in as a division to make life a little bit easier for you as well. So what we did in 2 steps here, we can actually look at it as a swap, which then becomes the 1 step. All right, next question. This question's a worded problem, so the first thing that we need to do is actually draw a diagram. Now, triangle PQR is right angled at Q. So the first thing that we know is that it is a right angled triangle. So we're just going to draw any old right angled triangle. And the right angle is going to be Q. Now, if we're looking at P and R, it actually doesn't matter which order we put them in. So I can put P at the top here and R over here, or I could swap them around But the important thing is when we put these bits of information on, they need to be in the right spots. So I'm going to put P at the top, R at the bottom. We're told QR is 41 meters. So QR is here, 41 meters. And angle R is 25 degrees. So there we go. That one is 25 degrees. The question says, find RP correct to the nearest meter. So RP is this line here, or PR, means the same thing. So we'll just give it a pronoun for now. I'm just going to use X. So that's the diagram that we're working with. So we need to work out what this length is, given that information and the right angle. So like with our previous questions, hypotenuse, line through the middle, tells us that's opposite, and this one's your adjacent side. So we've got information for your hypotenuse, information for adjacent. So, car, toa, you can see A and H is ka, so it's cos 25 degrees equals to 41 over x. X is in the denominator, so what we can do is swap the cos and the x around. So x is 41 over cos 25 degrees. Remember, this appears as a unit. Cos doesn't exist by itself. It always has to be matched to an angle. We'll put that into the calculator. So if you want to do it the short way, you can go 41 divided by cos 25 equals, and that's 41.24. To the nearest meter, that will be 41 meters. So with these questions, you just need to be very careful when you're writing out your equation. Make sure that you have your sides in the correct order in your fraction. Once you've got them in the right order, then you need to make sure that you're solving them in the correct way. And there's your questions.